We live at the bottom of a giant ocean, not of water but of air. This air, though invisible, is a fluid, just like the water in a river, and just like water it flows, exerts pressure, and changes how objects move through it. This is the world of fluid mechanics, a science crucial for understanding how airplanes conquer the sky. In aerospace, fluid mechanics is our guide to designing aircraft. By studying how air, our fluid, behaves, we can craft machines that soar gracefully above us. The shape of a wing, the design of a jet engine, even the paint on a fuselage are all influenced by the principles of fluid mechanics. Imagine a smooth, streamlined aircraft slicing through the air. This smoothness minimizes drag, the force that resists motion through a fluid. Understanding drag helps us build aircraft that use less fuel and fly further, crucial for both economic and environmental reasons. From the smallest drones to the largest passenger jets, every aircraft ever built owes its existence to the principles of fluid mechanics. It is the foundation upon which we explore the skies. One of the biggest mysteries of flight is how something so heavy can stay aloft. The answer lies in the clever interplay between an aircraft's shape and the air around it. Picture an airplane wing slicing through the air. The wing's curved upper surface forces the air traveling over it to move faster than the air flowing underneath. This difference in speed, thanks to a principle known as Bernoulli's principle, creates a difference in pressure. The faster-moving air above the wing exerts less pressure than the slower-moving air below. This pressure difference generates an upward force called lift that counteracts the downward pull of gravity, keeping the plane in the air. But lift isn't the only force at play. Drag, the force that resists motion through the air, is constantly trying to slow the aircraft down. Engineers work tirelessly to minimize drag by streamlining aircraft designs, using advanced materials, and optimizing every curve and contour. The dance between lift and drag is at the heart of flight. Understanding these forces and how to manipulate them is the key to designing aircraft that are not only efficient but also safe and reliable. Bernoulli's principle is a fundamental concept in fluid mechanics that explains how changes in fluid speed are related to changes in pressure. Simply put, Bernoulli's principle states that as the speed of a fluid increases, its pressure decreases. And conversely, as the speed of a fluid decreases, its pressure increases. Think of a garden hose. When the water is flowing freely, the pressure is relatively low. But if you cover part of the hose opening with your thumb, constricting the flow, the water speeds up and the pressure increases, causing the water to squirt out with more force. This same principle is what gives airplanes lift. The curved upper surface of the wing forces the air flowing over it to speed up, decreasing the air pressure above the wing. Meanwhile, the air flowing under the wing moves slower, maintaining a higher pressure. This pressure difference creates the lift force that keeps the plane in the air. Bernoulli's principle is not just limited to airplane wings, it's also crucial for understanding how helicopters generate lift with their rotating blades, how sailboats harness the wind to move across the water, and even how baseball pitchers throw curveballs.